Hey, Kurt.
Hey, who's that?
Dave.
Oh, hi, Dave. How are you? Yeah, we've got you penciled in right after me.
Okay. Well, it's not me. It's Chris.
Oh, it's Chris. Okay, good. Yeah, he's on.
Cool.
How about you, Natasha? Do you have any updates from University of Texas?
So I'm eating dinner. Basically I'm here. Not much to update, no. I'm a PhD student now.
Oh, yeah. Okay.
You mean in terms of like HPC general updates?
Do you know anything about the student cluster team at Texas?
Oh, I see. No, I don't know anything currently.
All right. Yeah, they have different leadership this year. I think everybody, I don't know, maybe they just decided to turn over the bunch of mentors they had because they've got a new crop of undergrads this year.
I see. Yeah, I haven't seen anything online about them. But it's been kind of hard to find information. So as soon as I do, I'll let you know.
Yeah, Stephen Harrell is there now. He moved from Purdue, and he'll be helping.
Oh, we will. Okay. Yep.
Oh,
Yeah.
an insider job, huh?
Yeah. He hasn't missed a student cluster contest yet.
Nope.
Okay, well, it sounds like we have all the right faces in the room. Let's officially call this to order. We got lots of good speakers tonight, so maybe we just get started. First, we have Kurt from MIT. I'll switch over to you here.
Okay, folks. The reason I put my URLs, if you look in the chat, I published my URLs to a web page on my on my default website. The reason I do that is because I have lost connection a couple times in previous meetups, so you will always be able to look at the URLs I'm talking about if I drop off the air. But I will also be quite quick. I'm certainly not going to talk past 7:30 Eastern Standard Time. So I attended the only IEEE conference we really run at MIT. There's a couple of smaller ones, but our big one is High Performance Embedded Computing. It's now called High Performance Extreme Computing ever since some of these new large, we used to have sessions that were just supercomputing and HPC and big memory and MPI. Well, now we have an AI subtrack and low precision tracks. And this year, and this was a great year if you like going to IEEE conferences for cheap, because there was a free option at this conference this year. And there was a couple of other IEEE conferences I went to this year that either had a free or a cheap option for students or faculty. This one had a free option. If you didn't want a copy of the proceedings, you could sit in on HPEC. And so if you go to the site and you look through the presentations, there was a little of something in there for everyone. If you want to go back to the top page there, Elliot, the little piece I ran on HPEC was the Open Supercomputing Birds of Feather session. Now, this historically was outside of the conference. We would get people to come in there and talk about generally oddball supercomputing initiatives. We were going to get John Gustafson to talk about his competitor to the floating point, the IEEE 754 floating point standard this year. But he was exactly 12 hours out from Massachusetts Eastern Standard Time. We had a lot of difficulty. We ended up getting a couple of people speak about their open FPGA initiatives, including, and I posted the Tactical Computing Lab slides to that web page. Dave D'Onofrio from the Tactical Computing Lab, he started the Open Supercomputing subgroup, and now we have the BOF at HPEC and we have the workshop whenever it gets accepted at Supercomputing. But I posted his slides up at my web page. So if you missed the BOF,
I'm good, thanks.
It was he had a really good presentation. There's rapidly becoming not too many competitions for the holy trinity of GPU, CPU, and interconnect that NVIDIA is going to be offering us pretty soon. But I think the Open FPGA initiatives might be one of them. It would be very interesting to be able to dynamically repurpose all of your resources based upon your workload, and I think that's the dream of the Open FPGA initiative. So go back up to the top there, Elliot, if you could. So I was complaining to Elliot that they double booked the ARM Dev Summit up against the NVIDIA GTC. And in fact, there were a couple of presentations that were simulcast because Jensen wanted to talk about the potential ARM merger. Now you can still sign up. If you see that link there, you can still sign up for the ARM Dev Summit up to the end of the month. Registration's free. And there's a little bit of something for everyone in there. Ron Minnick talked about Linux Boot because he has a lot of interesting ARM 64 ARM v8 platforms that he's putting Linux Boot and Linux BIOS onto. Ibn Upton from Raspberry Pi talked about some of the clusters that are built around Raspberry Pi. There's certainly new versions of Raspberry Pi. Ibn even talked about messing around with a RISC-V version of Raspberry Pi. Not HPC, of course, but still, there was a lot of HPC. It's really remarkable what ARM is doing in HPC right now. They claim to have the #1 supercomputer, according to Top 500 in the world right now, which is in Japan. So here again, I won't belabor that because that site is open till the end of the month. And anything you can't get there, if you look through the entire agenda, the 100 or 150 presentation abstracts, I can get you stuff that if you can't get at it. Certainly everyone that spoke at the ARM Dev Summit has a long history of presenting it at either ARM conferences or GTC or other places. Other recent conferences, I sat in for the first time on, let me go to the bottom one, the Oklahoma Supercomputing Symposium. Perhaps some of you have hit this before. Professor Neiman does this every year and had a spectacular turnout. I wish I knew more about this, but there were hundreds of people online for it, and they talked about a lot of the supercomputing topics that we talk about in our conferences. It's just that this was all very much of a geographical spin on it. He had a lot of people from Texas and Oklahoma and adjacent states talking about their HPC centers. It was really, really informative. Dan Stanzione, that I know our guest speaker tonight has worked with a bunch. He speaks apparently every year and brought everybody up to date on what they're doing at TAC and at the University of Texas. Here again, if the presentations aren't online yet, they will be in a week, certainly no later than the end of the month, and then you can go back in time. If you like what someone's talking about now, they certainly have a track record with talking about it in previous years. Then cluster computing, they have that every year, but it doesn't come around the US very often. It used to be we were consistently getting IEEE cluster in the US, I think every alternating year. It's probably every 3 years now. But there were some really interesting workshops at this one. How to properly meter out your HPC to be able to publish top 500 numbers, green 500 numbers. See if is there a link there, Elliot, to the workshop? Yeah.
Workshops, yeah.
The workshops, yeah. So certainly energy efficient HPC state of the practice. There was some really good stuff there. Here again, if it's not online yet, this was another IEEE conference that basically gave everything away if you didn't need a copy of the proceedings. If you wanted a copy of the proceedings, you'd get a flash drive in the mail. But it's remarkable. Most of the posters were available, and so if it's not live yet, I can get some of those presentations. That was a really good workshop. I didn't stick around for the entire conference. All right, what do we have? So that's most of the past conferences, except for GTC, which is what Elliot's going to talk on. I did have a couple of teasers there for upcoming conferences. For you folks that have never sat in on the Harvard Advanced Computing seminars, they're remarkable. They have them almost every Friday, and they've got one coming up this Friday that's going to be I forget the topic. I'll look it up while we're talking with Elliot. This Friday is going to be a really good topic. The last one was a guy who had hot rodded his computational fluid dynamic code. So these are all archived about a week or two after they're presented. Here again, probably something for everyone there. They had a Markov chain Monte Carlo expert. So I'll give you the links to the if they don't. I don't know if they archive the PPT presentations there, but they do send that link out if you sign up. The MIT equivalent of this is called CRIB, Computational Research in Boston and Beyond. And it is also on Fridays, so you kind of have to pick if you want to go to the Harvard ones or the MIT ones. And I don't think we have anything lined up. CRIB's only once a month, so I don't think we have anything scheduled for. Yeah, we've already had ours this month, so you'll have to wait until November for the next CRIB. I also put down, we'll have to vet this one through Professor Cayley. BARC, I put down Boston and Beyond Computer Architecture Conference, just in case. The last one was here in town. There is some talk that it might be in Rhode Island next time, but I guess that's all dependent upon COVID and the organizer.
That's the email I got today, yeah.
Okay. That's about it. I think so. We have a lot of the conferences that are scheduled at like PASC 20. PASC is the same week as ISC, but instead of being in Frankfurt, it's in either Zurich or Geneva. Here again, I can't believe they booked these HPC conferences the same week as somebody else's HPC conference. But PASC 20 is now PASC 21. They didn't move it. They didn't do it online. They just took they took a year off. The other conferences, I think they managed to get the oil and gas HPC conference in Rice in Houston. So it's a lot of oil and gas HPC presentations there. If you've never been to OG HPC, that's an interesting catch. They got that in just before all the universities shut down. I think they got that in the first week of March. That'll be back next year, pending here again, travel being back in vogue at the first week of March. Don't know about HPC for manufacturing. Those other links I had down there, I sat in on this. There's a site at MIT called the Industrial Liaison Program. They had a really good PMES presentation today, which they're going to archive. And in fact, it's going to be rerun a week from now. And it was dynamite. They had a lot of folks from material science talking about what kind of 3-5 materials we can look for to be able to use something other than 5-9s pure silicon for some of these fab designs. It was a really, really good presentation. So I encourage you to see it looks like it's a representation on October 21. I know they're also doing Spintronics on the 21st. So if you can't get hold of that after Moore's Law presentation that they did at 10:30 Eastern time today, I will get a copy of it for you. It was wonderful. And they had about a dozen grad student presentations There's a chap here at MIT RLE that has built a 32-bit RISC-V processor out of carbon nanotubes, and as a technology demonstration to prove that you can overclock these things and then let them run cool if you build them out of the right materials. That was a pretty interesting presentation. Now that one I can definitely get for you. He's done that presentation before at the Lamb Research Conference and some of those. So if I can't get the entire PMES workshop presentation for you from today, I can get parts of it, and that's certainly the 2 or 3 interesting bits we can get for you. So really, that's all I have. Everything else I can do. I had to put down on defunct there. I know Professor Cayley has been down to the HPCC that used to be in Newport, Rhode Island. I used to love that conference. It wasn't IEEE. It was just a bunch of people that wanted to run a high performance computing and communication conference. And I can't even find the URL anymore. It's disappeared and ended up in archive.org. And I know it went past 2014. It seems to me I was down there maybe 2 or 3 years ago, but it's no more. So maybe we can get a hold of some of those. Yeah. So I think you'll find some links, Elliot. I just don't think they're going to bring you to some website that's selling Viagra, I think. So.
Apparently so, yeah. Okay.
So that's about it. But guys, if you have any questions for me, I've been to a lot of these conferences. The UC HPC workshop is no more. This was the unconventional HPC, and that's the first one under defunct, Elliot. It was people who got flops out of some device that was meant for something else. So it turns out if you tear open your old, pre-millennial microwave oven, there's probably a Motorola CPU in there. So you can run Unix on your on your microwave oven if you're so inclined. And there were some pretty interesting designs. That was that link there, that Europar 2017 link, was the last one I could find a link to. I think they had it in 2018 and 2019, but lately it's become a subtrack of the Open Supercomputing Workshop at ISC, and we haven't even had that in like 2 years. So I don't know what the future of UC HPC is. It'd be great if we could have it here in the States, but it was a workshop at Europar up until I think 2 years ago, 1 year ago. Anyway,
so I don't know if you like prognosticating, but I know you're a RISC-V guy. Is NVIDIA going to push all the ARM users to RISC-V?
Well, there is an HPC, so there's probably about 10 task forces or subgroups underneath the RISC-V Foundation, and they recently put together an HPC subgroup. But I don't know. ARM caught up to Intel really fast, didn't they? Remember, ARM v8 was new.
Oh, it depends what caught up means, I think, to some extent. But
well, they've got this #1 supercomputer, so that's noteworthy.
All right.
That's in fact, so that cluster conference, you saw Satoshi spoke on Fugaku.
Yes.
So that's yeah. So they embraced to a great extent. They embraced open source. They recommend GCC as their compiler. So good on them. Good on them. So that's all I've got. Certainly email me if you have any other questions, and if my links are substandard, I can put you in touch with individual speakers or individual presentations. Especially if you're on MIT wireless, I can get into the MIT libraries once I've got an MIT IP address. It's great. Can't do that from home. So should we pass this off to Professor Cayley and he can introduce someone?
Yeah, thanks, Kurt. Yeah, go ahead.
So I'm happy to introduce Chris Bunn, who's the captain of the team that's for the Boston, one of the Boston teams in the cluster competition this year at SC. This particular team is made up of students from Northeastern and Williams College. Chris?
Sure. Thanks, Dr. K. I have a couple slides if I can share the screen.
Yeah, go ahead. I'll stop, and it should allow you to take over.
Just try to share my computer sound as well.
Yeah.
Oh, let me see if it's going to let me. Can you see my screen?
Yep.
Yeah, looks good.
Perfect. Hi, yeah, thank you everyone. So yeah, despite everything that has happened this year, I'm very excited to announce that Northeastern University and Williams College has come together to create a joint student cluster competition team. After some deliberation, our official team name is the Husky Cows, which is a combination of our school's mascots. And you can check out more information about our team and all that at this link below right here. So I thought the best way to kind of introduce our team would be we put together this 2-minute video on our team and kind of who we are, like what we do and like our workloads and all that. So I'll play this and then I can, I guess, elaborate on it further. Can you hear the audio?
Hello, we are the Husky Cows.
Yeah.
We're an intercollegiate team from Williams College and Northeastern University competing at SC20. Due to coronavirus, SC20 and our meetings have been entirely virtual. Despite these challenges, we've been working harder than any other year. 3 out of the last 4 years, Northeastern has selected a team for SCC and had strong performances each year. This year, we want to do better than ever, and we're going to do so by doing things differently. This year, we are bringing in different perspectives from another prestigious academic titan, Williams College. Through this unprecedented collaboration, we've brought together a world-class team of the best undergraduates and HPC veteran faculty members from each institution. Meet some of our members.
Hi, my name is Chris. I am the team captain for the Husky Cows, which is the Northeastern University and Williams combined team. I am a 5th year at Northeastern, and my workload for this competition is the Reproducibility Challenge, or METMEC-CT.
Hi, I'm Carmen. I'm a 4th year student at Williams College studying computer science and art, and this will be my first time at SC. I'm super excited to be part of the SCC this year, where I'll be working on the HPCG and IO500 benchmarks.
Hi, I'm Andrew. I'm a 3rd year CECS student from Northeastern University. This is my first time participating in SCC. I will be working on GROMACS. I'm interested in GPUs, high-performance computing, and everything about computer hardware.
Hi everyone, I'm Peter, and I'm a senior at Williams College studying computer science and math, and I'm excited about HPC because it's such a cool way to solve really large-scale and difficult problems.
Hi there, my name is Ritvik Rao. I'm a 3rd year computer engineering and computer science major at Northeastern University. I love GPUs, high-performance computing, and machine learning, and I'm excited to be a part of the SC team this year.
Hi, my name is Carolina Binns, and I'm a 5th year student at Northeastern University, and I am studying computer engineering. In this year's student cluster competition, I am focusing on the LinPack benchmark.
Yeah, so as you can see, this year I think our team is pretty special, kind of just, going out and partnering with another institution, especially kind of just having this diverse background of like team members and all that has been great. As you may know, Williams College is a liberal arts college, so I think that kind of background combined with Northeastern's more heavy like research-based background creates a very interesting combination of coursework, research experience, as well as like team member work experience as well. So as like a quick overview of the competition, if you're not super familiar with it, unlike in previous years, this year's competition will be completely virtual. So what that kind of just means practically, I guess, is all workloads will need to run in Azure Cycle Cloud. So I guess some of the pros of this is that it allows us to change our configuration for our workloads fairly quickly, compared to, I guess, in previous years where you had to build a cluster and you're kind of locked into that cluster for the entirety of your prep work all the way up through the competition. Being in Azure Cycle Cloud, obviously we have the ability to kind of scale up resources up and down as we need it. And it kind of allows us some additional opportunities to kind of experiment around and kind of tune a different set of parameters this year. In addition, we can also run all of our workloads at the same time without performance degradation. So where in previous years, we would need to kind of figure out how we're going to schedule all of our workloads so that we're able to finish everyone's applications in time. This year, we can kind of press play on all of our applications at once and use up the entire time to kind of just process through our applications. On the flip side, we kind of are locked into a more restrictive set of hardware selection. So again, where in previous years where we're able to kind of pull together our own cluster, this year, while there's a wide array of different architectures and different platforms available in Azure, it's pretty much fairly preset in terms of the type of hardware we're going to get, and in terms of, you know, different like configurations, I guess. In addition, they're also kind of locked into the Azure ecosystem for better or for worse, I guess. Broad overview. So before the competition, we need to optimize our workloads for our specific Azure instances. So this kind of involves going through all of our applications, reading the documentation and the source code, going in, getting an initial good first pass of our applications. And then from there, further iterating on our applications by swapping out different libraries, as well as tuning different applications for specific parameters. Once we get to the competition, ideally, all we would need to do is swap out, or is to just get the input files for the competition, drop them into our preset Azure Cycle Cloud clusters, and kind of just run it from there. Ideally, since we'll have a good chunk of time and the environment will be practically the same, we should be able to get a good grasp on runtimes as well. So it's kind of like a broad overview of the benchmarks and the workloads that we're going to have this year. As we have every single year, we have the classic LIMPAC, HPC, and IO 500 combo. IO 500, I think, is on the newer side. When I did SC, I believe in 2018, I don't think they used it. I think it's only something that's been fairly recent within, I think, SC19 and SC20. So I'm excited to kind of be able to work with that. LIMPAC and HPCG are kind of more of the classic, I guess, benchmarks within HPC. So always a welcome addition. This year's applications, the first one is CESM. It's a state-of-the-art climate simulation model. Kind of been doing a lot of good work on that. I think because it's mainly a CPU-bound application as well, so there's a good amount of kind of just optimization on the CPU front there. GROMACS is there as well. It's kind of a classic application. We should be able to get pretty good speed up, especially given the flexibility of the kind of clusters you can pull with Azure. The reproducibility challenge this year, which is what I'm working on, is a bit more interesting. It's definitely, I think it has something to do, it's pretty much has something to do with reconstructing X-ray CT like images together to create something, to create a brain tomogram pretty quickly. It's pretty interesting. It's GPU accelerated application, and the typical reproducibility like items such as like developing out a reproducibility paper at the end is kind of applies here. And finally, we have our mystery application as well. So because this year there's a little bit more flexibility in kind of changing hardwares and all that, I'm going to try to keep our general strategy to our general like broad strategy rather than go into more detail. But our general workflow has been so far is to kind of run and optimize our application on the discovery cluster first with the hardware that's the most similar. And then once we do that, we kind of transfer the files over to our Cycle Cloud instance, right that. They kind of make it fairly easy. So while initially we thought we would need to use something like, we thought we need to use some sort of containerization. It turns out that we have the ability to kind of just silo off each application to its individual cluster. So it kind of is containerized in that fashion. For CPU-bound applications, we're going to try to utilize AMD-based instances where possible. Lucky for us, Azure has a lot of options when it comes to AMD instances in the cloud. And kind of, I think in general, our kind of team's, I guess, shtick, if you will, is to use AMD-based hardware where possible. For GPU-based applications, we're going to be utilizing the instances that allows us to finish the application in the allotted time at the lowest price. Again, since we can start all of our applications at once rather than having to schedule them manually, we have some latitude in terms of how much time it takes to finish the other applications. Since we don't have to worry about an application blocking another one, as long as it kind of finishes within the same amount of time, and depending on what the grading rubric is, we're probably going to get the best price to performance ratio rather than the quickest running instance here. So while I think they've probably fleshed out a good chunk of information about this competition, I think given the fast changing nature of this competition and kind of all the logistics and all that, there's still a lot of unknowns that we still have. For one thing, I think the biggest thing is the competition budget is still not finalized. So essentially what is happening is once the competition starts, we're given an allotment of cloud credits to use. And we basically can use this entire credit to finish all of our workloads. We haven't received a concrete answer on what this will be. I think during the initial application when we submitted it, it said around $2,000. Another one said it would be 2 times the training budget. And the training budget, I think so far has been $710 or $720. So that would translate to around $1,400 or so dollars. Hopefully get some clarification on this soon, but I think this is definitely one of the things that has been holding us back from having a complete strategy. And another kind of unknown, I guess, is that we don't have a full idea of what the scoring rubric is, especially for this year, since we're given a final budget and an estimate. We're given like a final budget. It might come to the point where we need to prioritize finishing some applications over another. And so kind of having an idea of how, say, for example, the reproducibility challenge is weighted against a benchmark like IO 500. It might help us prioritize which application is going to get more resources and which one might have to sit in the backseat for a bit. So until we kind of know that, again, our strategy isn't super complete. That being said, I think we have a good plan going forward, and kind of, I think what has allowed our team to develop rapidly is kind of having access to the discovery cluster kind of prototype before we go to Cycle Cloud. So that's all I kind of have. I'm happy to take questions about our team. Thank you.
Chris, I got one quick question. I've always thought one of our value adds on the Boston teams was our access to grad students like Yash. Do you have access to grad students this year, or anybody who's a veteran of SC?
No grad students this year. I'm not sure if you're trying to find someone who wants to be interested in Dr. K, but I think I would be the person with the experience, seeing as I've gone to two.
Yeah, the student I would have mentor is actually at Pacific Northwest National Labs this fall, so the timing wasn't good.
Yep. Well, if we ever do quantum computing, I guess we can rope in Nick Matarese.
There you go.
So I know one team usually goes to any length to win the LinPack score. Is someone going to blow their whole budget on LinPack? You could do that, right?
You probably could.
You totally could, I think.
Yeah.
I wonder if someone's going to do it, but I feel like it wouldn't be as significant this year, given that it's all in Azure, I guess. Especially, so I guess in previous ones, you can kind of build a really massive, you can build like a really super custom cluster. You can kind of spec it out, and I think that's like super impressive. But given that it's all in Azure, it's like, it would have been like, all these other teams could just allocated to do the same thing. If that makes sense.
Yeah. I know that the competition is usually a slog, right? It's like multiple days, no sleep. Is this going to be submit your jobs, take a nap, and they're all done?
I hope not. So I think they still have the same.
Elliot, don't put ideas in students' heads, okay? What are you doing? What are you doing, Elliot? That was a joke. That was a joke, right, Elliot?
I think kind of, because I worry that you do that, you use up your budget without finishing any of your jobs. You make one mistake.
That happens.
Yeah.
So I guess it's being cognizant of that, but they still have, I think they still put out, they still set aside like 48 hours that you can submit it and all that. I'm personally taking off 2 days off of co-op to do it, so I'm kind of in it to win it, I guess.
That's awesome.
Hi, Christopher. I'm actually the captain for the BU team, so nice to meet you. I'm Ben. I just had a question for you about the cycle cloud thing and the strategy you said. So have you actually started exploring exactly how you're going to maintain your cluster for the competition? Like, are you going to have it running the whole time, or are you going to have some kind of persistent file store for your applications while turning off your actual cluster?
Yeah, I think we are looking into a persistent file store. We definitely can't have it running the entire time. That would just chew up through our budget, especially since we're considering like very pricey instances and all that. So I think we're probably considering one of the default ones that they have in. I think it's like BGFS or the NFS one. Probably the BFS one or whatever. We're still kind of looking into that, but yeah, we're probably gonna have a persistent file store.
Okay, sounds good. Thank you.
Yeah. Anyone else? If not, great. Thank you so much again for giving me this opportunity.
Yeah, thanks, Chris. This was great.
Let me stop sharing. There we go.
Okay, I can. I'll take the screen back. Well, maybe the right screen. There we go. Okay, let me jump through here. Okay. Okay, so recently NVIDIA had another one of their digital GTCs. They had one this spring and another fall. It's all online. So just like a lot of the events that Kurt was mentioning, you can go back and go through all of it. There's a lot of events and a lot of material you can get access to. First, I wanted to start with some noteworthy items that weren't actually part of GTC. NVIDIA launched a whole bunch of new gaming cards. Gamers is in quotes because traditionally there's a lot of research groups that use these things. Certainly for deep learning research, it's also common for quite a few of the HPC apps. You know, GROMACS users, for example, can use these sometimes. They're pretty cheap for how much compute you get. $700 is pretty cheap. It's a few $100s less than what they were charging last generation for one of the top end cards. And then there's this beast, which it's maybe hard to tell exactly how much bigger it is, but it goes like an inch, 2 inches over the PCI bracket on the left side there. These things will not fit in everything, and they are 350 watt GPUs, so they won't fit and they will overheat your box. So take care if you're installing them. And the other kerfuffle here was that a whole bunch of scalpers bought most of the cards and were reselling them for exorbitant prices. So you really can't get one of these right now. It's been pretty big news there. But yeah, good cards from a compute perspective. Just watch out for the heat and watch out for the physical size. And you'll see these two have this very iconic fan design. All the other board makers are making them with 3 fans and kind of other esoteric designs. There's a lot of heat in this generation. You can't stack these things up the way that you used to be able to. It's going to be interesting to see how people use them this generation. And the big difference between these and the professional cards, one of the big differences is the memory. These things have relatively little memory. Like this one has 10 gigs of memory. The Pro card has 48 gigs of memory. Pictured here is the one you'd put in a workstation. There's also a server version that doesn't have a fan. These things are going to be, $5,000, $6,000, tons of memory. And it's interesting to see NVIDIA's evolution. It's, they used to have one for graphics, one for virtualization, one for HPC, and now the lines are really getting blurred. One card can do a variety of tasks.
Those are still Gen 3, Elliot?
Oh, sorry. No, these are PCI Express Gen 4.
Oh,
so
right.
We don't have this particular card, but you should be able to push something like 25 gigabytes per second in and out of one of these cards. Really any of these, plus the A100 that's been out for a few months now. So very high data rates. Yep. And I hear rumors that AMD, I hope I didn't miss an announcement. No, AMD did have an announcement too.
They haven't announced yet. Soon.
Okay. I've seen a lot of rumor mills then. I've been definitely seeing articles online.
Yeah, it's coming.
So stay tuned. Yeah, it's a back and forth battle right now. All right. So other than these flashy cards, NVIDIA's keynote is on YouTube, and I've got links in here. So we'll share all this after, and you don't have to click along as we go. But NVIDIA's talking a lot about AI and everything. And everything from gaming to cities to healthcare, robots. It's all over the place. Pictured at the bottom is their big AI box, the DGX. You can use it for HPC as well, and some are doing so. So it's kind of one chapter at a time. A lot of this, if you haven't seen it before, is usually a packaging of tools you're already familiar with, right? So they've got this name now for visualization of all kinds. And you'll see some interesting things where they're training robots in VR, which I don't know if anyone here has been able to mess with, but it's an interesting idea. Rather than having to run the robots through real physical courses, they can run them through digital courses in addition to the real world courses, and get way more training in that way. It's kind of cool to see. And of course, tons on, this year, tons on AI for fighting COVID. I've got a cool little visualization. That last YouTube video worked, so let's see if this one does.
What does it do? Put a mask on?
It's just another one of those cool life sciences visualizations. Like if you've seen VMD or one of those tools.
Sheesh.
Was this the folding at home guy?
No. But it's exactly what it looks like, right? Right. So that's kind of what they've got in this slide here is all of the different aspects of tackling a disease like COVID. And it's a little hard to see, I know, but it's part of it is sequencing. So the genomics aspect of it. I know there have been genomic comparisons done now between the original SARS virus and the 2019 COVID virus. And they're tying that in with structure where they'll actually take cryo-electronic microscopy images of the proteins. They're finding out what this thing is physically shaped like, what kinds of medicines will properly interfere with its operation, and then they've got other little bits in here with imaging, right? So anytime you hear NVIDIA Clara, they're talking about healthcare, and it can be anything from GPU accelerated genomics to GPU accelerated visualization. There's obviously a lot going on now with literature searches where they'll take the entire compendium of literature on a particular topic and run it through an AI. Interesting. Yeah, that's being applied in a variety of fields, of course. So pretty interesting to see.
So the guy that was running folding at home said he's up to a zettaflops.
Yeah, they're at he's out of is it University? Oh shoot. University of Washington, St. Louis. Does that sound right?
Yes.
Bowman.
Yep.
Is it Bowman?
Bowman. Yep.
Yeah.
Yeah, and I don't think Zeta is it's Z-E-T-T-A. That's not a Greek letter, is it? Or a hurricane?
What did I know of?
So I don't know where they came up. Zeta.
Zeta. That's impressive.
Yeah, it is a number.
It's that scale out, right? There's a lot of inference, and I got to be honest, I don't follow the inference quite as closely in my day to day, but some of the ridiculous large resources have had to go into training some of these giant new neural networks. Some of the ones shown on the right of this chart here, like Megatron Bird and GPT-3. I forget if it was hundreds of thousands or millions of dollars of compute time that are needed just to train a network once with some of those networks. It's nuts. Now, what is cool is that a lot of times you can get pre-trained networks now, and NVIDIA offers that for some of the models, where you can get pre-trained or you can do transfer learning. So you don't necessarily have to start from scratch. And then obviously they're applying inference to, pretty much everything you can imagine. This is probably more interesting to this crowd. So NVIDIA acquired Mellanox, right? They're also acquiring ARM. And this is the chip that brings it all together. This and another one coming up in a second. So you've basically got, I think they might argue, a server on a chip or a mini server on a chip. It's got a fast network link. It's got GPU, PCI Express Gen 4 you see there. So it's a GPU, a CPU, and a network card all in one. It's going to be interesting to see what folks do with that. I mean, it's fun as an HPC person to dream about what people are doing about it, but it seems like what people are doing in practice with it is network security. So whatever. All the cloud providers put one of these in their bare metal servers. I don't know if we'll see these in practice, but it'd certainly be interesting to. And then you can see a little bit about the software stack. You might recognize a lot of this if you've used Mellanox cards in the past. Now Mellanox, of course, does InfiniBand traditionally, and then Ethernet. So some of this is more Ethernet technology than it is InfiniBand. And this is the big boy. If you were watching along earlier in the year, this might look a lot to you like what they talked about earlier in the year. So this is multiple 100 gig links with a pretty good size Ampere GPU attached to it. So you can kind of go low power or high power with it, depending on how much compute and how much data you need to push. I'm intrigued to see what people dream up with this. And of course, it's going to depend on the cost, right? This may not be approachable to most of us. So the other bit they've got is, again, going back to those pre-trained models, they're starting to provide almost, I don't know what you want to call it, like a pre-trained workflow where if you're starting up an online shopping site and you want to be making recommendations to customers, you can pull all these pieces together. You don't have to build it from scratch anymore. It's handy if you're doing that kind of thing. I don't know how general purpose these things are, though, that you can take them and use them for something that's not e-tail or online shopping. But it'd be fun to play with. And then we've got Internet of Things and Edge. And this, you might call this more of a use case than a technology. It's showing the bits already shared, kind of like network card with compute engines built in. They are adding some interesting capabilities here with security, where the models will be encrypted so that if you've got some deep learning box sitting on a shelf somewhere and someone steals it, they're not getting any data. They're just, they got your hardware, but they didn't get your data. And robotics, of course, robotics, autonomous vehicles, all over the place. So here's a little thing to play with. Now, Kurt, you use the big boys, right? You use the Xaviers. Do you use the Jetsons as well?
So they have they've got a brand new Jetson. What are they calling it? An AGX. So they came out with something between the last Jetson Nano and this, and I forget the exact model number, but it also has the Volta cores in it. So you can't go wrong if it had Volta cores. I mean, even if it does have only 2 gigs of RAM. I mean, they cut the price of the board in half because they got rid of half of the RAM. That's a bargain. Good Lord.
Yeah, it's fun to play with. I'm interested to hear the argument of the same software stack, because I know there were some folks that had to fight with some of the software stacks on some of these, or at least you had to fight with it if you wanted to do something a little more unique with it. But as they come closer to parity, maybe between these and the bigger ARM products, it'll be easy to move from one to the other.
Yeah, they're good boards.
Here's the speeds and feeds. Oh, this is Maxwell. It's not Volta.
Oh, is that right? Okay.
But you're probably thinking the bigger Jetson card that has Volta. I would suspect.
Yeah. All right.
Yeah.
Xavier, you mean?
Sorry, Xavier. Yes, Xavier probably has Volta. Jetson is on Maxwell. Thank you. And then ARM again. Right, so they're going to have ARM on these small little embedded mobile devices, ARM in servers on a card, if you want to think of them like that, and then ARM in the data center. Kurt mentioned at the beginning, right? ARM is on the #1 supercomputer. The US government has invested in some ARM systems. I think it's still niche as far as some of the smaller deployments, right? Like I'm not seeing, your average departmental HPC cluster thinking about ARM, but it'll be interesting to see just how fast. I've heard some say that these moves take 10 years. If it took 10 years for GPUs to really catch on, will it take 10 years for ARM to really catch on in HPC? I guess it didn't. Kurt, you're saying they move fast.
Yeah, and they have these task source out there to accelerate particular verticals. Certainly, NVIDIA publishes that list of HPC codes they've accelerated. So
yep.
On that route, yeah.
And just another reminder that this stuff is all online. Now, NVIDIA actually publishes all of the past catalog, right? So if you go to this link, you're going to see 1,500 sessions. Some of them are going to be from a couple years ago, but then you'll also see more recent stuff as well. There's so much to dig through. It's really worth it. There's a lot out there that, I talk to folks who have been working deep in the guts of TensorFlow for a couple of years, and they've still missed things. It's almost the busier we get, the less time we take to go look at resources that might actually really be helpful to us. So take a few minutes, see what's there. And that's all I got. If Elizabeth is ready, or if there's questions. All right, let's go to Elizabeth. Do you have slides, Elizabeth?
I do.
Okay, go ahead.
All right.
So we'll let Elizabeth introduce herself, but of possible interest to us is that she's a judge at the ISC SCC. So maybe we can butter her up and get a good score next time we're over in Frankfurt.
Well, I'll talk a little bit about that. That is a wonderful experience, and I hope everyone has an opportunity to come to Frankfurt. But I am Elizabeth Leek. I wear 2 hats. I work for the University of Iowa. I'm a research support specialist, which is a broad term. I do a lot of different things, but I also have a nonprofit that I founded in 2012 called STEMtrek. And this is appropriate because I'm as an international correspondent, I have the opportunity to attend a lot of different conferences around the world. And I've cherry picked from a number of keynote presentations for this presentation this evening. So we're calling it Don't Shoot for the Moon. And I'll explain that in a bit. But I see Dr. David Stack on with us tonight. Hi, David. That's David in this photo on the right, in the inset photo. STEMtrek was, we were brainstorming at one of the TerraGrid conferences. TerraGrid was the predecessor to Exceed, which is the National Science Foundation HPC cyber infrastructure. And this was a meeting of this particular group, our campus champions. And David was a campus champion. I was the external relations coordinator. Charlie Peck is there in the picture of Falling Water. We went on a side trip. That's what I miss about the in-person, are the opportunities to get together face to face. And frankly, STEM Trek probably would not have been born had it not been for that face to face. So I miss those, and I look forward when we can get back to those. But anyway, thanks for joining us, David. David is the vice president on STEM Trek as well. He didn't realize when he signed up that it would be a lifetime appointment, but we're never going to let him go.
We need to talk about that.
2012, when we started to coalesce, it was an election year. And this, they were highlighting all the problems in the world and everything in the sky was falling, and it was just awful. And I vowed at that time that we wouldn't compete for federal funds. And I can tell you now that the 2018 tax law changes really hurt because we were relying on tech company donations, but they no longer need the tax deduction. So by saying we won't support or we won't compete for federal funds and then having the tax law changes. This is why I work for Iowa, but what we do is we raise money for each workshop and event. And when we support travel to a conference, providing that we weren't under COVID, what we ask in return is a pay it forward pledge. And usually I find the people that pay it forward continue to pay it forward forever. And then there are some who never pay it forward, but that's okay. We usually get the scholars when they're grad and postdoc level, and I know everybody's really busy, but then some keep going forever. So we try to target veterans, workers that are displaced by automation, and lately COVID. I talked to a guy from a research group, his whole group had been shut down. So there are a lot of changes happening right now, aging workforce and people with disabilities. And here's a photograph of a typical cohort. This was a workshop held, co-located with Supercomputing 17. This one had a cybersecurity theme. And what I do each year is I allow the people that participate to fill out a post-event survey, and then they help shape what's going to happen the next year. And I find that it's very dynamic. I've been covering the HPC community as a correspondent since 2008. And every year there's something new and things change. That's one thing I like about it. But I'll also talk about how progressive, how quickly things are changing now. But there are 11 countries represented in this cohort, and half are from the US, and we favor people from EPSCoR states. And then the other half are mostly Pan-African. See, who else did we have here? A Canadian, and I think a guy from Nepal. So it just depends on who needs support to go to supercomputing. And if you peeled away the layers of the onion, the yellow box is new. The other slide is 2 years old, as you can see on the born millennial date. But I took the yellow box. I did a capture yesterday. This is mostly attached to me. Our Twitter is for STEM Trek, but my LinkedIn community is very large. So that's one of the reasons why people like me to correspond for their HPC conference, because when I share news, usually I publish through HPC Wire, but I'll also put it out through STEM Trek and my personal channels, and it reaches a lot of people, as you can see. Okay, why aren't I not progressing here? All right, this is a summary of the events that I typically either have in the past corresponded for, or I've been invited to be a speaker at, or I'm a member of the planning committee. I'm on the planning committee for the International Supercomputing Conference. I help with the travel grant and communications committees. And I'm also judge for the HPC AI advisory council sponsored cluster competition. And then I've become more involved with the South African Center for High Performance Computing Conference. And Kurt, that's one that you didn't mention that is growing. It's when I started, and I'm going to talk about the history, it was about, I think it was 200 when I first went for the 2013. And now it's up to 600 or more. And it's growing, I'll explain why, but so this is a snapshot. So if you do my muck rack, you'll see all the stories that I've written in the past, mostly through HPC Wire, but Datanami, Enterprise AI, Science Node, Inside HPC, Top 500, and Gridcast. Gridcast was a blog of CERN's, and for a while I covered the Open Science Grid and European grid infrastructure communities. So much different culture, completely different philosophically. I loved it and learned a lot from that community. So I've been doing presentations lately, and they seem to always have a similar theme, but because of my interest in workforce development, that's when people ask me to speak, that's what I usually talk about. And I've, in 15 to 17, we were chasing unicorns. We were suddenly deciding or finding out that everybody was looking for systems administrators, and we couldn't find enough scientific software development specialists. And these were skill sets that were becoming very rare. And at the University of Iowa, we had, in the last, in the last 20 months, within 15 months, we lost 3 systems administrators. 2 were students, and they went to work for Amazon, AWS. It's just a lot of churn. So it's really tough for smaller universities, public universities especially, to deal with the churn. That morphed into Myths, Magic, and Mastery, which highlighted mostly startups and correlations of how people, and I'll talk about a few of those in this presentation, but really almost supernatural drive to make a project work and over decades. And it's fascinating to me that someone can stick with something that long. And then 2020, the takeaway from this year, and the Be Agile came from the student cluster competition. My observations of the ones that prevailed, they were agile. They rolled with the flow. The Don't Shoot for the Moon, I'll explain that as well. So we're going to go the chronology now. 2012 was when I formed the nonprofit, and I started to get involved with South Africa, actually officially in 13. I wrote to Happy Sitola. He's the director. He was the director of the Center for High Performance Computing, and last year he was promoted. He now is over the network infrastructure, the data initiative for South Africa, Center for High Performance Computing, and he manages the Square Kilometer Array readiness sites budget and training project, which I'm involved with as well. So I wrote to him. I heard about Edward Snowden. Everybody's heard about Edward Snowden. And I was wondering what that would do, if we were making all these other countries angry with us because, the allegations were that the US was snooping and the US had a lot of control over the internet. And I worried what that would do for science diplomacy. So I was snooping around on the internet trying to find more out about what was happening. And I was afraid they would build a parallel network and they would ice us out. And I just stumbled across the Square Kilometer Array project. And I found out that there were 13 countries sponsoring it, and the United States was not among them. So I wrote to Happy and I said, Happy, do you need a correspondent? And within 2 weeks, my ticket was purchased, and I've been going back every year since. So don't hesitate. If you have a thought, what can you lose, right? So I get to go back to South Africa every year, except this year. I will not be there in December. I'm too chicken. He invited me, but In 2014, his conference was at Kruger National Park. And it is everything you've heard about it and then some. It's the most amazing place on earth. I absolutely loved it. We took safari drives every morning and every night. And then we did the HPC thing all day. And the conference center was, I think it had a grass roof. It was just very, it fit. There was a Bush airport too, David, you would have loved that. A little tiny Bush airport. We rode these little planes. But we were there with the wildlife, and it was a real challenge for the student cluster competition team because the power and the network kept dropping. But everybody had the same problems, so it was a level playing field. So in 2015, Peter Brahm was keynote, and Peter actually lives in Colorado, and I sent him this presentation over the weekend. We've been talking, and I captured these statistics on the square kilometer array in 2015. Now the target has moved. The number of countries that are sponsoring the project has changed. I know Germany dropped out at one point, but it is safe to say that it's the most ambitious project ever funded and ever conceived, as far as demands on compute and the networks and the software and storage and everything that will be used. It's going to set the curve. And the Workforce Development Initiative, and that little inset map, you'll see Southern Africa. You also see it on the wall behind me. That's my hand-drawn map. But that's the readiness sites that I spoke of. And each of those sites hosts, we have 18 data centers in, I think it's close to about a dozen countries now. And it's growing. It was Southern Africa, but now it includes Ghana and Kenya, and I think even Ethiopia. So those sites are preparing the workforce for the 50-year lifespan of the project. And they're starting their training with, was originally a ranger system that was at TAC. It technically belonged to the University of Texas. So when it was decommissioned, the University of Texas donated it to South Africa. South Africa was 20 some odd racks. South Africa broke it into parcels where they would set up 2 racks as a little mini cluster, new switch and new wires, and then they'd give them 2 racks for spare parts. And that's still running in many cases. University of Cambridge also donated a cluster, and then South Africa decommissioned a similar x86 class cluster. And one of the things Peter said in 2015 was that the computers, the software, and the data management methods needed to support this project have not been invented yet. And that really stuck with me. And then in 2016 and 18, everybody was talking about data. I covered the International Data Week in Gaborone, Botswana, and everybody was talking about fair data, fair standards. It was findable, accessible, interoperable, and reusable. Because they realized that 90% of the world's data had been created in the prior 2 years. And we needed to start to think about how are we going to process these data? How are we going to find them, access them, make them interoperable, reusable? So then in 2019, this is late 2019, this is back at CHPC in South Africa. Barali Renesha from the University of Chicago talked about a project called the Data Lifecycle Instrument. And that project pretty much satisfies all of the requirements of fair data, the paper that was published in 2016. It's everybody's answered their prayers. Globus has been taking off since then as well. Globus hit an exabyte mark this past week, I think it was. They've transferred an exabyte of data. So that was another thing that was, it stood out in my mind that, you know, we're going to change the way, we're not going to build the computers to facilitate mountains of data. We're going to reshape the data before they get to the computer. And that's exactly what Michaela Toffer talked about. And her keynote was about Internet of Things, sensor type technologies that employ edge computing so that the data are crunched and shaped before they actually get to the system. And that's a lot of the projects that I deal with in Iowa are agricultural in nature, or we have a big hydro engineering, part of our engineering college deals with hydro. So they're looking at flood surge and the effect of how the river basins are going to act with X amount of rain, et cetera, et cetera. When farmers need to plant, when they're going to be able to harvest, when they should fertilize, even wildfire management, how to predict where the next wildfire is going to happen. A lot of that science requires ground truth nodes. So that's what Michaela was talking about. Very important science, especially this year with all of the wildfires. And then in March of, actually that was October of 19, I was at the NCSA Industry Conference and I heard Matthias Carrasco-Kind speak about the Rubin Observatory, which used to be the LSST. We have any astronomers here? No. Well, the LSST is a large optical survey instrument, and it has NSF money. The National Science Foundation funds it, and I think 10 other telescopes. But the US National Science Foundation does not support the Square Kilometer Array. But I heard Matthias talk about observation data, and I recognized a lot of the same tools that were being used or talked about in the context of SKA, where SKA are radio data. So they're completely different kinds of data, but it's the same universe. And we're interested in the same events that are happening in the universe. So when I was at the October conference, after Matthias spoke, I asked Bill Gropp, I said, Bill, is there going to come a point in time where LSST and SKA will need to compare data? So if we hear ET calling through the SKA and we see him waving through the LSST, should we match those up and make meaningful results? And he said, well, yes, there could definitely be a point in time. So he paid for Matthias's trip to South Africa. So that was in October. December, Matthias was in South Africa. So then that helped bridge the diplomatic ties between those two instruments. And also in late 19, I should add that the NSF did support the transatlantic cable that stretches from Brazil, Sao Paulo, I think it is, Brazil, and Luanda, Angola, which was a big deal. So that's all in place to support this traffic, the astronomy, and a lot of agricultural data as well. Food security data will benefit from that. So the other keynotes at CHPC were Thomas Sterling. And of course, anyone at MIT probably knows Thomas Sterling. I think Kurt said there's a statue of Thomas Sterling somewhere. Well, Thomas was talking about the future being non-von Neumann architecture. And I've got a reading list later in this presentation, which I'll share, and you can read up on that, which I didn't understand a lot of what he was talking about, but when I pressed him for translation, it was exactly what some of the others had been talking about with the threat of the end of Moore's law. And that's what Bill Gropp spoke about, which I have on another slide. So John Gustafson was also a keynote at this conference, and he presented on the topic of posits-based KPU architecture, which Kurt brought up. That was part of the HPEC meetup. John was supposed to talk, and that's where I saw Kurt, because I went to stalk John to see what he had to say. But John has spent about equal time in government labs, private computing companies, and academia. He started out in Iowa. He's an Iowan, but he's now in Singapore. He was 35 years perfecting posits. And he said he had a big breakthrough as far as HPC in 2016. And he started to develop an HPC platform in 2017. And what is interesting about John is he doesn't conform to conventions. In fact, his ACM membership is lapsed. He's not a IEEE member, or he's never been a IEEE senior fellow. He, at one time, the hardware manufacturers tried to get him to quote, dumb down the math to fit the hardware. And he said, no, I'm not going to do that. It's the math prevails. It's all about the math. He's the only person I know that when he speaks about math, his eyes twinkle like diamonds. It's like he really loves this stuff. So he really captured my interest because this is all starting to come together. The dots are starting to connect for me because I've covered enough of these keynotes that they're all starting to sing the same song, but in a slightly different language. But he's very happy in Singapore. He said that IEEE, there are people that have pressed him to register a standard, but he's not ready. He would like to see more success stories. And it's tough in the US because government funds tend not to support what has been deemed experimental hardware. And as far as a grant, writing a grant for this, but that I have reason to believe is changing. The National Science Foundation, Manish Parishar's roadmap or blueprint, it was called the Blueprint, was published in April of 2019. There's a section on innovative platforms. So some believe that this is going to be a little more liberal when it comes to experimental, innovative hardware. So I hope that's the case anyway. And I love that John's an open source evangelist. And I think of all the slides in his deck, this is the one that resonated most with me. There are two images here. Now, if you saw just the one on the left, you might not think that's Abraham Lincoln. But with the one on the right, your brain says that's Abraham Lincoln. But the one on the left with all the higher level of detail is a lot more intent. There are a lot more pixels there than the one on the right. So what he gets at, and that makes sense then with this slide, better accuracy with fewer bits. And there's a sweet spot indicated by the pink line, whereas the IEEE floating point is the green line on the top graph. And for some things, not everything, they're getting really, really good results. And when I say they, there are development teams at the University of Washington, at Rutgers. Some hardware development is being done by Simunova in Stuttgart, Peter Gottschling, and another place in India. So he's distributed, he's got a lot of people helping, but when I spoke with him over the weekend, and he's like, oh, we had another breakthrough. So he sent me a whole bunch more information. And he's just so excited about this. Some of the early adopters are seeing 30% efficiency in storage and energy, which, when you go back to the square kilometer array, should they adopt something like this? Sure, the learning curve is going to be big, but when you look at that efficiency, that translates to money and time. Potentially having the cost of, for those projects with abundant data challenges. And it is being commercialized by Stillwater Computing. And again, these are the people involved outside of academia, and then Rutgers and University of Washington are helping as well. So then we go to the AI data conference at the University of Iowa, and I met Michael Abramoff. And he has a startup called Digital Diagnostics. He developed the first FDA approved fully autonomous diagnostic instrument, the first ever. And it is for diabetic retinopathy. And when you look at, it was interesting to me because I know vision problems are a big problem in the really poor regions of the world. And usually it has a link to poor nutrition. So in India, this would be transformative. In Africa, parts of Africa where I work, it's just extraordinary. And he thought he had it ready to go in 2010, and he presented it to FDA, and they rejected it. They said, you haven't considered racial and ethnic bias fully. So he went back to the drawing table and he optimized his algorithms for another 8 years and submitted it again, and it was approved. So he said that there was a point in time where people were really mean to him in the press, and they called him the retinator because he was, diagnosing things. And they said, well, isn't this going to take business away from you? You're a specialist. You should be capitalizing on these, diagnostics. He said, no, because it can take weeks, even months in some places to even get to a specialist. And time is an enemy of anybody with diabetic retinopathy. So by putting this instrument into the hands of a standard caregiver, primary caregiver, you can cut the time, you can get the diagnosis earlier, get them in queue for that treatment phase. And he is working on a fully autonomous treatment as well. So the instrument itself can be driven by someone with a high school education, which is just extraordinary. So that really impressed me. And here are a few slides. I won't go into detail, but it is the #1 cause of blindness in working age adults, and it's preventable. And that's the heartbreak when it's preventable, but it's impossible to get care. Either the specialists don't exist or the money isn't there. So this AI will make it affordable for many more to be treated. And I'll share this with you. You can dig into the details here, but some of the high level figures here, I got you covered up. 15% of patients actually get treatment. And with this, they project that 90% can get treated. And so I was thinking about the connection of Iowa. Here, Dr. Gustafson on the right, he makes jokes about having Trump hair, but I don't think it looks like Trump hair. And then Dr. Abramoff on the left. Had they stayed in one place, had Gustafson not gone to Singapore, had they had an opportunity to work together sooner, it made me wonder if Abramoff could have come up with this even quicker than, the 8 years it took him to perfect those algorithms. So I spoke with him after I told him I was making this presentation, and he said, oh, by all means, share my slides. So I hope he actually meets with Gustafson someday, or maybe helps write a science driver for a Stillwater system, which would be really exciting. So one of the last keynotes I heard was Bill Gropp, and he spoke about speculation, the death of Moore's Law, the end of Moore's Law. He said it's not going to die for another 10 years. But I have to wonder if posits will change his mind. But you look at the stability, if the graph on the right, the scatter chart, and the stability represented by transistors, Moore's Law being every 2 years, the hardware will double in capacity and halve in price. That no longer it started to fail in 2004, I guess it was. And then there was another keynote that said in 2014, there were more indicators that it was dead. But I look at this from a workforce development standpoint. The stability from 1970 to 2004, you could pretty well count on how to train someone for this community. But lately it's all over the place. So that's a real training challenge. And my takeaway from that, oh, and here's the 1 exabyte, a quintillion bytes transferred by Globus this year, which is just phenomenal. That happened, I think, last week. So as far as training, I'm very interested in student cluster competitions. And I've been a judge at the ISC event now for 3 years. This year was all virtual. And it was the first time it was virtual ever. And it's really made me wonder why we haven't done some of it virtually in the past, because some aspects of it worked really, really well. And other aspects did not. So there were 14 teams, and the ones that did really, really well were agile. They hit the ground running when they all had to use the same node on the same system in Singapore. And that created huge bottlenecks, latency problems. And I think they weren't the only users. There were also researchers using that node in Singapore. So of the 14 teams, 11 of them whined, oh, we had bottlenecks, and oh, we couldn't get in, and da. The ones that won, oh, we couldn't get in, so we developed a VM and we did this. We developed a multi-user hack. That was one somebody came up with. And they were the ones that did the best. So I guess my advice, in whether you're competing in a cluster competition or you're preparing for your career, is, this was a Thomas Sterling quote: don't shoot for the moon, aim for where it will be when you get there. And that was something he picked up when he worked at the NASA Jet Propulsion Lab. And it was his favorite saying for, the moon's moving all the time, or you're moving in aspect to the moon. So prepare yourself accordingly. And I think with training, that's what we need to look at. One of the pitfalls in education, having worked for higher ed pretty much exclusively most of my career, we have a very structured, the academy is very structured in general. And if you try to introduce something new in the form of a 4-credit, for example, it has to go through layers of approval, and it takes months and sometimes years to get your idea put in place. I'm kicking around the idea of offering a certification program if a grant that I've written gets funded. And that has required a lot of, well, you just can't offer a certification. Oh, it's not approved, and it'll never meet with our standards, blah, blah, blah. But by the time you get it through, they're on to something else. So I'm very interested in creating a more dynamic education and learning platform that won't encumber people with debt as much as, here I work for higher ed, but the average student has $29,200 in student debt. And when I interviewed the winning teams I interviewed about a dozen teams in 2018. I mostly wanted to know why there were no US teams in Frankfurt. And I wanted to know why US teams weren't in the top 3. What could we do differently? And by interviewing a lot of different team captains and advisors, I boiled it down to 3 things. The ones that win consistently have a vast amount of support from their government and their university. They get time off to train, and they get a lot of financial support, so they don't have to fundraise on the side. In the UK, students have about the same amount of debt as they do in the US. So those students from the UK and the US usually have to work outside of school, so they have very little time for extracurricular activities. And that matters, because when I interviewed, for example, the South African team, they have no debt. They get bursaries, so their education is covered. And one competitor had developed 131 models with one application. And the judges were calculating what the hours that would have taken her. And, you know, just the expendable time when you're a full-time student, there are a few that have that time. So they get a lot of support, and they don't have the debt. That's the second thing. And then the number of events. I was interviewing the Chinese team that won in 2018. And that team captain went to MIT, by the way. Bai Chen Li, he's somewhere there. But, you know, he said, oh gosh, you know, we get a lot of support. And I've spoken with other people that have been involved with their program, and they actually celebrate them. They're celebrated much like we would celebrate sports heroes. And that's another cultural difference I think we could work on, is celebrating excellence in this particular event. And the number of events that Bai Chen had been to, I think he said 7. Some do 2 and 3 a year, or 7 over a student career up to, which is a remarkable number, which it's not uncommon for American students to just do 1, maybe 2 in their career. So those are the differences that I noted for what it's worth. And then I've added some links here to support how I arrived at these conclusions. So you can take the journey with me. And I'll conclude with, we are having a Science Slam event for SC, which actually they're due on the 16th. So you have 2 days to prepare. You didn't have anything to do tomorrow, right? You could go work on your video. This is you have to turn in a video that is between 5 and 8 minutes long, and it needs to have a theme. We have 6 categories. So if you visit the STEM Trek site blog, you'll see a link that gives you the link to the instructions. But the prizes, we have a dozen SC full tech program waivers, and they're worth $675 a piece. We have first and second prizes in 6 categories, and then a grand prize that's over $5,000. And that would take you to South Africa, to Kruger National Park in 21, because I'm hoping that's where it is. So please take tomorrow off and make your video. And it's not restricted this time. Usually we only allow people to benefit from our programs if they're from an EPSCoR state or Pan-African country, but this year it's open. I've already got 2 from Stanford, so I hope everybody will compete. Another thing I wanted to mention is in the next, I hope if my collaborator steps up, we're going to, the HPC AI advisory and Gabriel Consulting, which is Dan Olds. You may remember Dan from the competitions. We're launching a survey, and we want to find people who have competed in competitions in the past. And it's basically, where are you now? How did this affect your career trajectory? And the prize for that will be, I'm saving 1 SC registration waiver, so it'll be a drawing. And then Dan's getting his hands on gift cards. So watch our site, we'll publicize that soon. So that's all I have for today. Thank you. I'll open it up for questions.
Elizabeth, did that survey go out already? You haven't sent that out yet?
No, I think Dan was working on getting gift cards. He wants to sweeten the pot. Okay. We've had bad luck with surveys lately. People just don't take the time. So
how will you know who to solicit? Do you have a list of previous competitors, or?
I have a list from ISC from 1 year, but I'm really looking for people that have been involved in the past if they kept track. Otherwise, just general, my social capital, 18,000, whatever. You know, word of mouth. Yep. So yeah, because it would be good. I think that way, you know, going back to the challenge of getting money out of tech companies are pressed lately to see a return on investment. And if they can support a team and see that that's going to translate to, you know, this many now work for my company, and they're the innovators and the people that are making the big decisions, we need to support more of this activity. So yep. Hoping once they see that, they'll give us all more money.
Yeah. Well, the Department of Energy has been a big winner at the Student Cluster Contest.
Good.
I think they probably get an employee a year out of it.
That's good.
Yep.
Yeah, I just know anecdotally, and I just thought we needed a survey.
Hmm. Okay.
So we have any questions?
What's the best way to follow along on what you're doing? Is it LinkedIn or Twitter?
Actually, you can follow me on LinkedIn, Twitter, or Facebook. You can look at the website occasionally or set your alerts for new content on our website. 'Cause that's usually the routes that I take.
Thank you.
So you mentioned the advisor from Tsinghua. I think he's been to Student Cluster Contest every year. I see him listed as an advisor again at Supercomputing this year.
For the Chinese team or for MIT?
Zhidong. What's the last name? So he did some sort of a postdoc at Stanford. So he comes to the U.S. a lot.
Mm.
But man, Tsinghua must have won LinPack, what, 8 years in a row or something?
They are, and you know, every now and then, in the last 5 years, South Africa and Tsinghua have been neck and neck.
Oh yeah, that's right. That's right.
So close. You know, South Africa is so well balanced.
Yeah.
That any one of them can answer the questions you ask. Now with the Chinese teams, the English barrier is tough, so usually they route through the lead. But they're equally balanced as well, and they agonize over the details.
Oh yeah. Yeah.
Definitely put the work in.
Well, and to Elliot's point, I think there was a team that had like 16 GPUs last year, Elliot, or
yeah, was that the one where they turned the fans off, or was that a different year?
that was last year, yeah.
I think they bring 16, but they might only be able to use 4, depending on the power threshold. I know is a big thing at ISC. They have to keep it under under a certain power threshold. But
yep.
Yeah, some of them come with, they get a blank check on the hardware. It's just amazing.
Oh, sure, yeah.
But it's such a wonderful opportunity. And this summer, we interviewed them. They were all at home, and home is a different place for different people. It underscored the fact that some don't have the internet at home, so they had to meet in an unusual place to meet with us. And then others, you know, you could tell they were in student accommodations, and I said probably a third of them were in an attic. You could just see from the architecture they were in an attic. But a lot of enthusiasm. It was great, even though some complained about the problems, but everybody had the same problems.
Yep. That was dynamite.
So I highly recommend it. I'm really excited that Benjamin Lee's getting interested in it and involved. It'll be fun. I've been chatting with him privately. I thought maybe that might be Bai Chen, because sometimes different Chinese, they have different names in the US, but I said, you need to find Bai Chen, because he would be a good advisor, unless he's tied to Tsinghua and he has a commitment there. But he's very nice. He helped me a lot when I wrote that story in 2018.
Oh, good. Yeah. No, we'll chase him down. Elliot, did we have any other lightning talks, or is that everybody?
I think that's everyone, and we're pretty much at time. So definitely thanks again, Elizabeth. That was great.
You're welcome. Anytime. And if you want me to try to rope John in, or Theo from Stillwater sometime.
Yeah, well, so we have talked about having this meetup at a different hour. It's certainly when most of us are working from home, it doesn't have to be at 7 p.m. Eastern time. We'd have to do something to accommodate Singapore time, that's for sure.
Well, John's not a fan of online. I think with HPC, you might have heard him grumble.
Yep.
He doesn't like it, but Theo's in Maine now, so he might join.
Oh yeah, okay.
He would be a good one, actually.
We'll have to get Professor Leeser involved. She did an analysis of posits versus floating point versus IEEE standard ones. I remember, I believe she presented that at HPC. Does that sound right, Professor Kelly? Is he still online, or did he have to go? So
I'm
she
still
knows.
here. I know she works on precision. I don't know what she. If she
Yep.
did.
I'll dig up some of her papers. She was very interested in, accumulating and error correction on. I think that was an IEEE 754 standard paper. So, yeah.
Interesting. Well, it's very nice to see everyone. And again, thanks for the opportunity.
Oh, yeah.
Thanks again.
Yeah, we'll be in touch, Elizabeth. Yeah.
I would,